We've got half an hour, so I want to talk about what Nix is. I have to talk about that, that's mandatory. I want to talk about how Nix works and how I use Nix. Who's more interested in how I use Nix? Okay, and now who's more interested in how Nix works? Okay, that's pretty even. I'll go with how I use Nix. I think that's slightly one. So has anybody heard something like this before? It's pretty true, isn't it? What would be the first step to the right direction to fixing this problem?
A new solution.
Functions. So Nix actually gets closer to solving this problem by using functions. It's when we say we use Nix or I use Nix, it's actually can be a bit ambiguous because it's three kind of separate things. First of all, it's a programming language for specifying builds mainly, but it's just a general purpose programming language. It's lazy. It's also untyped. I think I'm the only person talking about an untyped language at Lambda Jam, so that's pretty ironic, seeing as at work I'm known as the typed person. But it's a programming language that you could theoretically use general purpose. We use it for specifying builds. There's an interface built on top of that for actually building and packaging software. And then it's NixOS, which is an operating system. So when we say we use Nix, it can be a bit ambiguous to what you really need. And each one of these is built up on the other one. If you're using the package manager, you're actually using the programming language underlying. And if you're using the operating system, you're probably using the build manager and the programming language. Does that make a little bit of sense? So Nix has been around for quite a while. It was actually started as a research project at a university, and it came around about 2003, so it's been around for a while. I have only been using it for about 2.5 years. Late 2014, I started using it on a Mac. Shortly after that, I said, I'm not using this Apple stuff anymore, and I installed NixOS on a MacBook, which can work, is not the greatest. Since then, I've switched over to using better computers. NixOS, I had to kind of go the whole way. I decided that after using Nix on a Mac that I wanted to go a little bit further, and so I started using NixOS. If you look at this, I got this from somewhere, I can't really remember where, but it's there's a web page that analyzes GitHub projects and figures out how popular they are based on contributions, based on issues and pull requests, and it's number 3 of all of GitHub. So Nix packages is pretty huge. So Nix packages is where we put all of our package management, and it's basically where all Nix code goes. If you write some useful Nix code that's generally useful and not just useful to yourself, usually goes into Nix packages. So VS Code is a little bit more popular. But otherwise, Nix packages has got a lot of activity. It's gotten really, really popular in the last couple of years. So it's been around since 2003, but it's started to get really popular. So some of the benefits of using Nix is that we get code reuse because we've got functions. Functions are a really good form of code reuse, right? Reproducibility, so if we compile once and we compile again, we're going to get the same thing. If you compile something and I compile something, we should hopefully have exactly the same output. None of this, at the moment I work in Node.js, and when I install packages and someone else installs packages, we don't know whether they're going to be the same, and that's a problem. And atomic upgrades is something that we can get, and we get rollback as well. So when we do atomic upgrades, we can upgrade a whole set of packages at once, and you don't have an intermediate state where some packages might work and some packages might not. You can just upgrade them all at once. And we get rollback as well. So what would a function for building look like? Anyone want to guess what the input is? Any dependencies? Dependencies is a good one. Anything else?
Compiler flags.
Compiler flags, that's a good one. And source code is another one. So source code, dependencies and any configuration for actually building. And what will the output be?
Binary.
Binary is a pretty good one, yeah. Or you can see it as a description of how to build a binary. So this is the first Nix expression we're going to look at. This is actually a function. The top thing we could think of as a record. We call it a set in Nix, and these fields here we call attributes. So we're taking 2 attributes in an object, standard ev fetch URL, and this is the definition of building something called hello. GNU hello, it's actually a program that you can go and download and compile. And what's interesting is that we specify the source. And so we actually specify the hash of the source. So all inputs have to be specified, right? And this is how we specify this tuple that we want to build. So when we instantiate this, we get this DRV file. So you see there's a hash here. I've had to truncate it because it's 32 characters and won't fit on the slide. But there's a hash, and it spits out some DRV file. You can use PP term. Supposedly A term is a format. I don't really know anything about it, but you can pre-print it, and it looks something like this. And so you can see that everything's pretty explicit. You've got a lot of the hashes. And see the out up the top, that's where we're going to compile into. That's what we want. When we actually build this, we want to store it in the out directory. And we've got lots of, this is all environment variables. So all these environment variables get set. This is the command to run bash. We're going to run bash, but we're going to run this script up here. Does that make some sense? How we're going to, this has got all the information we need to build this project, right?
Possibly.
Okay. So this default builder looks a bit like this. And so we go back to the standard env. So like that. So standard env is something provided by Nix packages. So when we did this instantiation, you notice how we put Nix packages in here? It's providing those two arguments that we had. So remember how we had standard env and fetch URL? Nix packages is doing a little bit of magic to basically specify where standard env and fetch URL come from. Okay, so that hash that we had before, notice this hash? That is derived from taking out the out. Notice how we had the out before? So if we take the out and we hash that, then we get this hash. And then we specify that's where we want, that's the derivation file. And this, the store, then we fill that in from the same hash. It's a similar hash. It's hashed in, there's a couple more details in that one. So we put this hash in here. Oh, sorry, wrong one. This one, out. So out is hashed from the specification. This is like a whole specification for building. This hash comes from that. So you can see it kind of like this. So we give them the inputs and the content, and the mask content is the one without the out directories in it. We get some hash, and then we use and then for out, we have a similar hash. So with outputs, there's actually two different types of outputs. We can have just normal outputs that we use and build, but then there's also fixed output, and fixed output is something like this, where we specify what hash we expect. So notice how we're specifying the hash that we expect of this content, but if we were to build the hello, we're not actually specifying what we want as the output of hello, right? We don't know what type of binary hello is going to be, we just know how to build it. We don't know what hash it's going to generate. So the hash of hello comes from the whole derivation, which you can see here. And the hash for the table comes from being specified. Does that make sense?
Flip back to that other page. Please.
Yep.
Okay, so what you want is reproducible builds, right?
Exactly.
So I'm looking at things there and wondering, are they fully specified, like
Mhm.
builder, for instance?
Yep. So this?
Yeah, so that just looks like a path, not a hash, right?
Okay.
Or is
Repeat the comments.
oh,
Yep. So the comment is he wants reproducible builds, and he's not quite sure that this is fully specified. For example, builder doesn't look like it's fully specified for some reason.
yeah, well,
There's a
yeah.
there's a hash. Yeah. So bash is supplied explicitly. Yeah.
Okay, yeah. I just don't trust things about hashes.
Okay. There is a hash. There is a hash. That's meant to be 32
Oh,
characters,
yeah.
but I've had to truncate it to fit on the slide. Sorry.
Yeah, okay. Thanks.
Okay. So everything goes into Nix store.
Does it do anything special for things which rely on the clock?
Is there anything special for anything that relies on the clock? There's quite a few hacks around that, yes. It works pretty well. So anyway, default builder we run, that's our builder. It looks something like this. It has a heap of phases that it goes through, and for each one we're just going to evaluate it. So unpack phase, patch phase, configure phase, and the whole code here I think is so that if you override any of these in your derivation, then it will run that, otherwise it'll use the default one. Default one looks like this, or this is all really like truncated and hacked up versions of the real thing. Like if you want to know what the real thing looks like, I can show you, but it doesn't quite look like this, but this is close. It'll run the configure script with some configure flags. prefix is the big one because we're doing prefix is not there, but it's the out directory. So if you remember before, the out comes from there, the out. So we're saying we want to build into this directory, and prefix is the common way of doing that on using make files and configure scripts. So the configure script, we say compile into out, and then we run the configure script. And this is install. And install, we just pretty much run make with some flags. And these are the default ones. You can overwrite any of these, but the default one is to compile make and, to do configure, make, and then make install. Does that make sense? That's the general way to build software, and that's the default one that's kind of built in. And so for for hello, this will just work. It'll just run the configure script to the prefix directory, run make, and then run make install. You'll get this output directory created. Oh yeah, you can see make. It makes the directory. So it makes the directory, puts all the files in there, and you're done. So that's the way of realizing, they call it realizing that derivation. Is anybody confused so far? Okay. So if we were to actually realize this, and we had, there's an idea of binary substitutors. And so Nix has got a built-in one which uses a build server called Hydra. And if we were to realize this, it would actually go and fetch the output from Hydra, because it'll go to Hydra and say, hey, do you have this cached already? And then Hydra will say yes, and then send it over to me. So I don't actually have to build it. Because it's all fully specified from here, we were able to calculate the hash, which is this hash, and then ask Hydra for that hash, and it's got it for us already built. If it didn't have it built, we'd build it locally. And because it's fully specified, we should realistically get the same output. Does that make sense? And there's this really cool hack where we haven't specified, notice how we haven't specified the runtime dependencies, we've only specified the inputs. So here, see those see how standard env, bash, and hello are all inputs to this derivation? We haven't specified which ones we need at runtime, right? So the way Nix figures that out is by looking for those hashes of each of those inputs in the outputs and using that as a heuristic to determine whether we're going to need it at runtime. If it's got a reference to one of those inputs in its output, we probably will need it at runtime. For example, if it's a dynamically linked library, we might, and it's got the hash to that referenced, we'll probably need to load it up. There are various ways to control that. You can strip, if the output refers to too much, you can actually strip that out, and if the output doesn't refer to enough, you can actually add that information in, but by default it just looks at the hashes of the output. And it's all stored into the SQLite database so that Nix can query it and figure it out. You can use it for something else in a minute that I'll talk about. So profiles, so that's basically how the Nix works as a build tool. As a package manager, you can install packages using nixenv, and it creates these profiles. And these are just symlinks. So here I'm doing a read link, and you can see that it's linking to some profile that's been generated. Nixenv generates these profiles, and the path on my machines just has Nix profile bin. So this symlink keeps getting updated. So if we were to install a package, it would create a new profile. So you see how this one had profile 276. So I've installed and removed and upgraded packages 276 times. And when I do that again, I get 277. And that gets symlinked. And so then I've got that executable in the path. Does that make sense? It's just updating symlinks. So one question might be that if I've got, what happens to the profiles after I update it? When I get a new profile, what happens to the old one? Anyone want to guess?
It's on garbage collection.
Yeah, garbage collection. So once we have created a profile, we can actually, for this case, I've said delete older than 60 days. So I can actually go through all the old profiles and say, was it created more than 60 days ago? If so, delete it.
There's no garbage closure, like troublesome. So you're saying older than 60 days?
Yep.
Is it possible for something to reference?
It will only delete it if there are no references to it. Yeah, yeah.
I assume the Nix shell on its own is broken for that because of the underlying stuff.
Nix shell theoretically could get garbage collected while you're in a Nix shell, yeah. Yeah, I'm pretty sure. Don't do garbage collection while you're in a shell, I guess, I think. Okay, so Nix packages is where we do all of our work. There's a lot of packages in Nix shell, Nix packages. At the top level, this is pretty rough. This is not quite accurate, but there's roughly about 7,000 packages at the top level that you can install. We actually mirror Hackage. All of Hackage is mirrored into Nix packages. So we get 11,000 Haskell and Hackage packages. And then we mirror all of R packages, I think, which is CRAN, if anyone does any R, CRAN, I think. So in Nix packages there's also NixOS, and we have a lot of build support for various different formats, such as virtual machines and Docker images, and building Debian and RPM packages, and also various things like language support. For example, there's Stack, Haskell Stack support in there. And there's just various little tools that you can use to build various things. If you wanted to use, like this is an example of using the Haskell packages specifically. Nix shell is a way of entering a shell which enters like a bash with a heap of different environment variables set. So what this will do is set an environment variable where path has GHCI on the path. Does that make sense? And GHCI is configured such that it has all those packages available. And we can package your own things. Cabal2Nix is a tool that we can generate build descriptions. So this is actually a Nix expression, and you can see it needs a lot of arguments passed in, so we need to pass in all of the dependencies basically, but this Nix packages cool package will do that magic and pass in all the arguments to that. And so we can build a Haskell package using that. One question I get often is how to pin. So we're trying to get determinism right. Well, if we do an import Nix packages, that's importing whatever's on your environment variable. So Nix packages has to be a, there's something called, echo. So this is where Nix packages come from. So it comes from this. So Nix automatically manages this for me, but that's where the Nix packages is referencing. And so when I do a Nix channel update, so there's the idea of channels, and you can update it and that. So they kind of have like a mutable reference to Nix packages. And so people ask, if I've got this mutable reference to Nix packages, but I want it to be fully deterministic, how do I fix that? And what you can do is use that mutable reference to Nix packages to fetch a deterministic version of Nix packages. Does that make some sense? You're using Nix packages to download a different version of Nix packages that you've specified because you're specifying the hash of Nix packages. And then you can use that to build whatever you want. And you know at that point that you're always building the exact same thing because you've specified what version of Nix packages you're at. Does that make some sense? That you've fully specified every dependency that you possibly could have? Cool. So I use something called NixOS. I've got like 5 computers at home and they're all running NixOS. I refuse to run pretty much anything else. NixOS has like a configuration file that is described using Nix, the programming language. So this is something like what I've got at work. I've got a lot more as well, but something like this. And so if I were to run, so you can see that I've got things like Docker installed, allow unfree so I can install things like HipChat, a couple other things. So if I run NixOS install, if I've got a blank system, that I have to have the device set up, like so I have to have the disk formatted and things. But if I run NixOS install, it'll install it onto that disk. And once I've got that running, I can do Nix rebuild switch. That'll create a new copy of my operating system that I can switch to. Well, it automatically does switch over. It actually does start up systemd. So if you're running any systemd services, if it notices anything changes, it will try and restart those systemd services or shut them down or start them up. It also does things like switches over. It changes the symlink, so your path will get updated to the new binaries and that. So once you run switch, it'll automatically switch over to the new setup. There's a couple of things like boot level settings and stuff that won't automatically get switched, of course, because you can't do that at runtime. But some of it, like a lot of it will. And so if you do switch, it'll actually install a configuration. This is my grub. I use grub at work, and this is what it looks like. And so you can actually see that it installs a new configuration into my grub installation. So if I want to roll back, I want to go back to the previous version. If I've screwed something up in my settings, I can just go back and start running the previous setting. So when I'm doing anything with video cards or anything in Linux, I always screw that up. So this has been really useful for that. And so you might have noticed that this is referring to system config and referencing some init here. So when it boots up, it boots Linux, of course, but we've got these couple of variables to use. And so the system looks something like this. It's got all of my software installed, and it's got a couple of binaries and things and various configuration and that. So anything to do with actually booting my operating system goes into this profile, and it's using the profile mechanism like I showed before, so you can roll back or you can go forwards, or you've still got them all, and you can garbage collect them. This is what NixOS's bin and user bin directories look like. So they don't actually have anything installed. What happens is they all get configured once you boot. So none of these get changed, but everything, like your path and everything, gets set up when you boot to have all the stuff that you want in it. So this is the, this is the init file that we're booting up in Linux. So the init file has wants all these utilities that it can boot. It sets up some descriptors in your dev and creates a directory, puts sh in there, so that's how that sh got put in there, and copies these etc files. You might have some files, configuration files. It'll copy those into your /etc. Your user groups is represented as JSON. It'll set that up. So that'll set up your password and your groups and your shadow and everything. And then it does more setup. That's how your end gets created. And then it finally links what you've just booted into your current system, and so you can reference your current system. Okay, so that's how NixOS works. Anybody written one of these before? Yeah, it's not fun, is it? So good thing about Docker files is that they're like we get immutability from them. When you build a layer, it's actually an immutable layer. But one of the downsides is that you get side effects. So has anybody tried to build like a 3-year-old Docker file before? I've tried to do that, and it doesn't work, does it? Yeah. So there's a couple of problems with building a 3-year-old Docker file. One of them is that packages sometimes get renamed. Like Node.js might not be Node.js tomorrow. It might be IO, for example. Even if you pin a version, so you say you want Node.js, I don't know, 0.10, 0.1 or something, that will get eventually deleted from the apt repository. And so you got it's side effects. There's actually a really good quote from Eric Meyer, which is that most of the functional programming doesn't work. If you've got one form of side effects, then you've got a lot of side effects. You need to go the whole way and go fully functional. So Nix has got some support inside of Nix packages to build Docker images. This fully specifies a Docker image, for example. And so we're building a layer on top of Alpine. And we're saying, put Redis in there. I've done this before, which is I've had a configuration that I've used for NixOS, and then I want to reuse it to build a Docker image because I didn't want to have, because you can use NixOS configuration for quite a lot of things. I'll show a couple more things in a minute, but I wanted to use it for a Docker image, and so you can actually specify, take the configuration, the configured system from that configuration that I've written, get the etc files, get the top level, put that into where it usually is, put env in, because building a Docker image from scratch, there's no env, and bin sh, put everything that you'd need to boot a Docker image into the image. And variables you can actually specify variables inside of a Nix configuration. And so if you were to build something like this, you get something like this, which is a actual Docker specified image format. And if you had that, then you could load that into Docker. And so I've done this before at work. I've built a Docker image with a heap of Haskell packages. We've got like an internal HipChat Lambda bot thing. And so I've built a heap of Haskell packages, like 800 or so, put them into a Docker image, and then built it using Nix, put it into a Docker image, loaded it in, and pushed it up to a repository.
So just to recap, that was like a Nix like system description or configuration or whatever, it wasn't Docker specific and it just worked for Docker.
Yes, exactly. Yeah, it was not a Docker specific configuration. It was just a configuration like I had before.
And
Here, something like this.
And you could have had several of them. You could have had like one with like your editor setup.
Yes.
And one
Yep.
with your like
Yep.
networking, whatever.
Yep. So these configurations, they've actually got like, see how I've got imports at the top? So imports, you can kind of import a lot of things, and so you could import my editor setup. You could put a lot of things in there, yeah. And so I could build a Docker image based on that same configuration that I run on my laptop, yeah. It's, of course, not going to be exactly the same because it doesn't have all like the boot configuration and that, but the files I can put in there, yeah.
Yeah.
Okay. So yeah, it generates something like that as well. So it's fully Docker. One thing, if you want to test out a NixOS image, so like you've changed some thank you. So you've changed some configuration and you want to run it in a virtual machine. You can test it out by using like we use QEMU. So this will actually build a virtual machine of your current configuration. So if I wanted to build a virtual machine from my laptop, I can build that and I'll have all my configured software installed and available as a virtual machine that I can boot. I could also build an ISO image. So if I had if I wanted to give someone a copy of my operating system to install, I could just build an ISO from my configuration. And did anybody go to the PureScript workshop last year at Lambda Jam? A couple of people, yeah. So if you went there, you got an image that was built by Nix. This. It doesn't have to be this complicated. I wanted to build a specific image format, so VDI. So I wrote some code to. What this does is there's a script make disk image which generates a QEMU disk image. Which is just like a raw actual disk image. And then you can use QEMU image to convert from a raw image to a VDI format, which is like, I think, a appliance image that you can import into VirtualBox. So, yeah. And the last example I want to show is me building some software for my router. So I've got a router that I plug a big hard drive into, like a terabyte hard drive into, and there's no good software for syncing from your device to some other device. So I think like the best I found is rsync. And so I wanted rsync on my router. It didn't have it available, so I decided to cross-compile rsync to my router. Also had to be statically linked. Usually Nix packages doesn't really do statically linking because we like to put everything in the Nix store and have it all dynamically linked so we can optimize it and garbage collect it. But if I have to find like a general function static arm, which would just put on some flags to enable static compilation. And this is not very good. And the cross-building stuff has completely changed since I wrote this. So this is a pretty old example. I didn't have enough time to update this into the new stuff because I don't really understand it yet. But the new stuff should be a little bit cleaner than this. But what we're specifying is that we want to build it for ARM because my router's an ARM system. So using the same package description of rsync, I didn't have to modify how rsync gets built. I just had to run a function over that description. Is that pretty cool? And has anybody else tried installing like a cross-compiler before on their system? Yeah, it's not very, well, I found it not very fun. So this is good. I never had to deal with actual cross-compilation. I just had to build this until it worked and modify the C flags. Okay, so there's a couple of tricks that Nix uses to work. Patch shebangs. If you have like hashbang, user bin bash in a script, obviously before when I showed that what's in user bin, there's only env, so we don't have that. So patch shebangs will actually modify it to whatever's on your path. So it sees this bash here and says, oh, well, I've got a bash over here. Let's use that one. Patch elf is similar, but runs for binaries. So if you download a binary, it'll reference this lib64 LE Linux. We don't have lib64 on Nix because everything's in the store. So what we have to do is update the interpreter to be a dynamic linker that we've got in the store. And then we might have references to dynamic libraries. And so there's the rpath configuration in elf, which is where you say, look in each of these directories for dynamic libraries. So we can actually update this binary to look for file there in zlib. Does it make a little bit of sense? because we can't just rely on user bin or user lib 64 or user lib or whatever to find libraries, because we don't have that. So we're trying to specify everything. So we're saying, look here and look there. And then there's lib redirect. So if you've got software that really wants to reference something outside of the next store, you can actually change it so that you can. So you put this on your preload, and it'll actually hook into like all these syscalls. It'll hook into all those syscalls and rewrite those syscalls to be something in the next path. So you can actually say, instead of looking in example.conf, look here. Okay, a couple of projects. NixOps is for deploying systems. DisNix is for deploying services. GUIX is a version of Nix that gets rid of the programming language and replaces it with Scheme. DOL is a configuration language that's typed. So if you want types and you want to do Nix, use DOL. And Kubernetes is a way of deploying Nix stuff to Kubernetes. We want to redesign the CLI a little bit because it's a bit gross. We want better Windows support. Anniversary update came out, and we can actually run Nix now on Windows, and we can actually run Windows binaries in Nix, which should do better than that. And we want better documentation. If you look at the documentation here, there's 3 different manuals that you'll have to read to fully understand Nix, and that sucks. So we want to do better than that. Okay. Thank you.